we know what vector fields are, let's talk about vector line integrals. We did scalar line integrals last section. Now we're doing vector line integrals. And let me just say this. Vector line integrals are far, 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 far more important for us than scalar line integrals. Okay, so vector line integrals, what are these? Let me kind of start off with the following example here. So let's say that it is a windy day out, and I'm kind of drawing, these purple arrows here are corresponding to the winds at particular points. And let's say that and this is representing some kind of, the plane here. And let's say that you're riding your bike. And you're riding your bike, along this curve here. The question I want to ask is the wind helping you, or is the wind hurting you, or is it doing neither? Is the wind helping you, is the wind hurting you, or is it doing neither? And so the wind is blowing in the same direction as you are, that's helping you. So, for example, right about in, take a look at this purple arrow, I just highlight as blue here, that is mostly blowing in the same direction as you. Like this other blue arrow showing like your direction of motion at that point, that one's showing the winds. It's blowing mostly be from behind you, a little bit to your left. It is mostly helping you. Something like right here, this wind right here, you're moving in this direction, the wind is blowing in that direction. That looks pretty perpendicular to me. The wind's really not helping you or hurting you. I'm trying to see if there's a place here where the wind is hurting you in this picture I just kind of drew real quickly. I'm not seeing anything, but you could imagine that if this was your direction of motion here, and the wind is going in that direction there, that's very much hurting you. You're biking straight into the wind. And so we want a way to add up all of this stuff. We want a way to be able to say, hey, here the wind helped you a little bit, here the wind hurt you a lot, here the wind wasn't really helping or hurting you. How do we do that? So we want to add up lots of little small calculations. That sounds like an integral to us. And really, what are we thinking about here? We want to think about this sure is suggestive of dot products. So if F here is our vector field that's representing in this example wind that's blowing around. If F is representing the vector field, and if T here, T is a unit tangent vector in the direction that we're going here, it looks like we're thinking about the dot product between our vector field and this unit tangent vector. Alternatively, we could be thinking of, this as having a little being parameterized by some function r of t here, and so we could be thinking about just a little chunk of motion along here, dr. And so take a look here. Here's our formal definition for a vector line integral. Let F be a vector field with continuous components defined along smooth curve C, parametrized by r of t. T runs from A to B. Then the line integral of f along C is the integral of f dot t the integral of f dot t ds along C is the integral of f dot dr ds. Ds along C is the integral of f dot dr. So this is the f dot t. That's kind of how we first came up with it. Computationally speaking, we go with this integral of f dot dr form. So it's a little bit interesting. Our integral has a dot product in it. You know, the integrand just naturally comes with a dot product. Okay, so this is closer to how we're going to actually do calculations with it. But take a look here. This is really the algorithm that we're going to have to evaluate a line integral. Assume that you have some vector field f. You need a parameterization for your curve here, curve C. The first step is that you need to substitute in this r of t into f to get f of r of t here. You need to compute the derivative of your parameterization, dr dt. And so then down here, the way you compute the line integral is that you take your f of r of t, you take the dot product of f of r of t with r prime of t, and you integrate that where t runs from a to b, the appropriate bounds here. So this is our definition of a vector line integral, and we'll be doing lots of these calculations during the rest of the section.